All right, good morning, geometry students. Today we're going to take a look at how to do some calculations of area of two-dimensional figures. We will be using these formulas and calculations in an upcoming chapter, the next chapter actually, but hopefully a lot of this seems familiar to you. Area of rectangles, squares, triangles, rhombus, all the trapezoid, all the different figures. So we're just going to kind of review those. Some of these formulas you will need to know, and we'll talk more specifically about that as we go along. So square, rectangle, parallelogram. So notice all three of them. We always think about the same calculation, the base times the height. I know sometimes we think rectangle, we think length times width. I mean, base height, same idea. You're multiplying the sides together. The same on a square. Of course, we do know from chapter 7, all the sides on a square are congruent. And we've seen our parallelogram from chapter 7, back to it there. And again, we're still using base times height. So square, rectangle, parallelogram is all base times height. So you're filling in there on your note sheet on the star, the base and the height of the square, of course, are the same. We should know that from chapter 7. So let me just give you a second to write, and then we're going to do some easy calculations here. We'll find some areas, some rectangles, squares, all of the things. Then we'll get to triangles. All right, let's do it. So of course, find the area of the figure below. Number 1, of course, is a rectangle, is always just our base times the height. So 12 times 5, 60. You know we like to label. Remember area, we're doing centimeters times centimeters, so centimeters squared. Over here, of course, we have our square because we have our congruent sides. Still the same formula, base times height, but they're both the same. A little mental math, of course, 4 centimeters, or sorry, meters on this one, meters squared. Let's clean that up, we got it. So again, nice, easy calculations, formulas you probably recognize. All right, a little different, but still using the same formula here. So it says to find the unknown side length. So this time they tell you what the area is. So I know instead of 8 equals, I'm going to write 91.3 equals. And then of course I'm going to do the base, 8.3. And we're looking for the question mark over here. I know some of us don't like the question mark. We like to just use X for that, which is totally fine. And we know to solve for X, we're going to divide off our 8.3. Here, of course, is where you're going to need your calculator. Punch that in, and you are going to get 11. And I'm going to label. Now, this is just the length of the side, of course, so no centimeters squared. It's just plain centimeters for our label. I mean, that's really as wild as square, rectangle, or parallelogram gets. Let's talk triangles. We've seen area of triangle, of course, base times height over 2. So we're going to be using that again today. Now, just one thing we need to talk about, because we've seen some different triangles. We've seen, of course, a right triangle. We've seen an acute triangle. We've seen an obtuse triangle throughout the chapters. So one thing just to be conscientious about that I'm going to mark on these pictures, of course, your height always makes a right angle with the base. So this is going to be a right angle too. This is going to be a right angle also. So that's an important detail when we're looking for the height. So we do need to fill in on our notes here, this little star. The height is the segment that is perpendicular. And remember, sometimes we like to use the symbol, you can too, to the base. So we have to make sure for the height we're looking for that perpendicular segment. So let me give you a second to fill that in. And we'll do some area triangle problems. All right, let's do it. So find the area of the figures below. So of course we're using our base times height divided by 2. So I can see our base here. We've got our 4.8. Our height is, mine's in red, of course yours won't unfortunately be. I know that that red segment is the height because it's perpendicular, and we are over 2. Easy peasy, we're just going to type that in our calculator. It doesn't say what to round to, so if you just want to put 8.6, that's fine. Usually I know we go to the 10th, and we are in feet squared. Feet times feet, feet squared. All right, another triangle, so same formula, base times height over 2. So I'm taking a look at this one. Of course, our base of our triangle right there is 4. And again, mine are in red. Our height is this perpendicular segment. And of course, we are over 2. So punch that guy into your calculator, and we are going to end up with 8.2 inches times inches, inches squared. Like it, nothing too stressful yet. Okay, kind of like the rectangle problem. This time they're going to have you find a missing piece, and notice they tell you what the area is. So instead of writing 8 equals, I'm going to put 45.8 equals. Now remember, we're doing the base, which is what we're trying to find. And I know a lot of you like to just use X for that. Me too. And of course, our height is that red perpendicular segment. And as always, we are over 2. So now we're going to use our good algebra skills. We're going to go through and solve this. I'm going to multiply each side by 2. Got it? So again, you can just punch in your calculator 2 times 45.8. We got it. So 91.6 I'm going to put. And usually we like the variable behind the coefficient. I'm just going to flip these and put it 8.8x. I know you guys are great at solving equations. Divide that off, and we are going to get 10.4. I'm going to label, remember that is the side of the triangle, so it's just inches, not inches squared. So a little bit of algebra. All right, so we've covered rectangles, squares, parallelograms, triangles. Let's do a trapezoid. Now, we've seen this formula. It's been a hot minute since we've done it, but we have seen this before. So area equals, of course, your height, and then base 1 plus base 2. We're going to add the bases together, and then, of course, we're over 2. Now, same rule applies on the triangle as it does on the trapezoid. Your height has to be perpendicular to the bases. So that's what we're filling in down there on the star. Remember, for your bases, it doesn't matter if you think of this bottom one as B2 and this one as B1, because we're adding them together. The order you add doesn't matter. We just know we have to add those bases together. All right, once you have that written down, let's flip the page and let's do some trapezoids. All right, find the area of the figure below. So of course we have our trapezoid here. So my bases are my 2.8, my 9.6, and obviously the height is the 9.5. So I'm going to do the height, and then it doesn't matter what order you add the bases because we're adding 2.8 plus 9.6. And remember, we are over 2. Again, you just punch that into your calculator exactly how it looks, and we're going to end up with 58.9. I'm going to label, we're in miles, and it's area, so we're doing, of course, miles times miles, miles squared. All right, let's do another trapezoid here. So again, first things first, let's identify the height. Mine's nice and easy since it's in red. And then our bases are 7 and 3.2. And again, you're adding, so it doesn't matter the order you jot those down. And then, of course, we're over 2. So type that into your calculator, and you will find that the area of this trapezoid turns out to be 15.3 miles squared. Okay, we're going to also see a lot of circles coming up in the next chapter. So circles, probably that formula looks familiar to you. Circles, of course, we're using our pi r squared. We just had a test over chapter 10 circles. We all know the radius is from the center to the edge of the circle. Now remember, radius, of course, is also half of the diameter. Nothing wild about a circle. Find the area of a circle with radius 6 centimeters, round to the nearest 10th. Okay, so area equals, of course, pi times radius squared. Now, easy way to punch that in, we all know 6 squared is 36. I would just punch in 36 and then our pi key here to try to get it as exact as possible. So, and again, it says to round this to the 10th, so I'm going to put 113.1. And we are in centimeters squared. Got it. All right. Find the length of the radius of the circle that has the area of 254.4. Okay, so kind of like the other ones where we're finding the missing sides, this time they're telling me what the area is. We are going to solve for the radius. So pi r squared. Yes, I put the dot in there just for multiplication for dramatic effect, but you know it's multiplication between them. Now, I'm trying to, of course, solve for the radius. So first thing I'm going to do is divide and get rid of the pi. And we can punch that right into our calculator. So I'm going to go ahead and do that right now. I'm going to do 254.5 divided by pi. 254.5 divided by, here's our pi. Got it. Now I'm just going to leave that, I mean, that's a pretty easy one. I guess I can jot that down. You could just leave that, of course, right in your calculator, because I know you know to get rid of squaring, we need a square root. Well, we can square that root that, of course, in our heads. If you had a not nice number like 81, of course, you can have your calculator do all the work. Remember, second negative key cuts and pastes in your previous answer for you. I'm pretty sure the square root of 81 is 9. All right, so we got it. Our radius is 9, and we are in inches. All right, so many figures, so little time. So last couple figures we have to cover are rhombus and kite. Rhombus and kite. So you can see the formula for the area. You're going to fill this in on your note sheet. Diagonal 1 times diagonal 2 divided by 2. And that formula is true. You can see on the left side, remember our rhombus is our 4 congruent sides, but it's not a square because you do not have all right angles. And then, of course, on the right figure over here, we can see we've got these 2 congruent sides, and then these are congruent to each other. We've got our kite figure. But, of course, the calculation, the formula is the same, half the product of the 2 diagonals. So we're just going to multiply the lengths of the diagonals, divide by 2. So I'm going to give you a minute to jot all that down. Of course, make sure you have the formula up here at the top. Diagonal 1 times diagonal 2 over 2. And again, once we get to some formulas, let's talk about, do you have to have them all memorized? Some of them, like we should know area of a triangle, we should know area of a rectangle, we should know area of a circle, some of those basic ones. But we will talk about a formula sheet when we get closer to the test, what you have to know, what you don't have to know. But some of these basic ones you do need to know. All right, let's do some of these. So, of course, we've got a rhombus here in our first picture, 4 congruent sides, no right angles. Doesn't matter, same formula. We're going to multiply our diagonals, and it doesn't matter if you do the 8 or the 6 first. The order you multiply in doesn't matter, and, of course, over 2. No calculator needed here. 8 times 6, 48. 48 over 2, 24. And let's label meters squared. All right, we have our kite here for B. Same formula. We're going to multiply the diagonals. 7 times 10 over 2. Again, no calculator needed. 70 over 2, 35 centimeters squared. All right, at the end we like to kind of jazz it up here a little bit. Don't let this scare you. Still the same formula, still the same process. But of course, us, have to plot this figure and take a look at it. So let's start plotting the coordinates. Again, we're going to be conscientious about our points and labeling. So J's at -3, 5. K's at 1, 5. Let's see, we've got L at 2, -1. And M's at -2, -1. All right, let's connect it. Looking good. All right, so first let's identify what type of figure that is so we know what formula to use. Well, I'm taking a look at that. That is a parallelogram. And remember, we're not going to get carried away here, but just I love to review. If we're going to take a look, if we want to prove or justify that it's a parallelogram, I would, of course, count the slope, like maybe between J and M, rise over run, rise over run. That should be the same number. And then same thing on the top and bottom. The rise over run are the same on those purple sides, opposite sides parallelogram. Now that tells me my formula. That is our base times height. Okay, so let's take a look at it over here. So really easy. I'm just going to count the base. 1, 2, 3, 4. Got it. Now remember, the height, of course, has to be perpendicular. So if I count the height, now that yellow segment, of course, makes a perfect right angle. I mean, you could do this one also. They're going to be the same. Count it. 1, 2, 3, 4, 5, 6 units for the height. I know the yellow doesn't show up the best, but you got it. 4 times 6, 24. Now, I don't know if it's centimeters, meters, inches, whatever. I'm going to put a generic label on units squared. That wasn't so bad. We just had to draw the picture. All right, the next two have the pictures drawn. Clearly, A is a triangle. We don't need to sweat that anymore. So we know base times height over 2 for the formula. Now, our base, of course, I can just straight count how long that base of that triangle is. So I'm just going to count 1, 2, 3, 4, 5. Height, remember, is always that right angle, always perpendicular. This is a right angle right there. Your vertical with your horizontal intersects in a right angle. So there's my height. I'm going to count that. 1, 2, 3, 4, 5, 6. Of course, over 2, 30 over 2, we got 15 units squared. And the final problem. All right, let's take a look at this one. Of course, first we need to identify it. This is a parallelogram again. Now, just like I talked about on the previous slide, opposite sides are parallel. You can count your rise over run on each of them to justify that. Base times height for the formula. So of course the base, I'm just going to count one of the bases here. 1, 2, 3, 4, 5. The top is also 5. Remember, opposite sides congruent. Now height again is that perpendicular segment. So there's a height. I mean, all of these would work. They're all the same. I'm getting carried away now. You can just straight count the height of those red segments are 3. So we're going to have 15 units squared for a final answer. All right, easy stuff I know today, but like I said, we're going to be using these formulas coming up on the end of the next chapter. We're going to need those. Now, your worksheet, easy peasy. We're going to knock that out. It's going to be due by the end of the hour. You should have no problem finishing that up. All right, have a great day. See you tomorrow.